Hello, my name's Christopher Bell. I'm going to be talking about the new capability in Primer 20, which allows you to convert a dummy into a mechanism. And I'm also going to show how this can be used for examples such as pedestrian impact outside a car. First, a quick recap of the existing dummy and mechanism capabilities in Primer. On the left, we have a dummy. This is a very hierarchical organization of assemblies. You'll have a root assembly, which is typically the lower torso. That will have children, maybe the upper torso and the upper legs, which will have grandchildren, the upper arms, lower legs, great-grandchildren, and so on, down to as many generations as necessary. On the right, we have a mechanism, in this example a seat, and you can see that there are multiple connections between the base and the seat cushion, and then further multiple connections between the cushion and the seat back. There is no rule about what is connected to what. Anything can push anything else around, and it's generally a much freer sort of way of moving things. Historically in Primer, mechanisms and dummies have been allowed to work together, but in quite a restricted way. The dummy, here blue, can be defined as a child of the seat, here red, and the motion of the dummy can be driven by that of the parent seat. You can think of it as being a stick where the yellow arrow is drawn here, in which the motion of the seat cushion actually drives the motion of the dummy torso. But it's a one-way treatment. The dummy can't influence the seat, and connectivity between the two is very limited. This means that it's not really suitable for the problem of pedestrian impact outside a car, where we have a much more general configuration to consider. Here's an example of a dummy model outside a car where the concept of a child dummy sitting on the parent seat simply isn't going to work. We've got a dummy on a bicycle. The bicycle needs to be able to move, the handlebars need to be able to rotate, the pedals need to be able to go round, the wheels need to rotate, and we simply couldn't do that with the existing parent-child relationship. So in this example, we've converted the dummy to a mechanism, and we've connected it to the bicycle in 5 places. You can see here 2 hands on handlebars, 2 feet on pedals, and the dummy's buttocks on the seat. And in the next slides we'll show how that's done and how it actually ends up working in practice. So how do we do this? First of all, we have to convert the dummy to a mechanism. There are 2 ways of doing this. The first one is from the dummy panel itself. You can now export a dummy definition to become a new freestanding mechanism. This leaves the existing dummy unchanged. That's not affected at all. You end up with a new mechanism definition in your model, which is effectively a copy of the dummy, but formatted in a different way. The other way of doing this is in the mechanism panel itself. When you edit a mechanism, there is now a new import button, which allows you to bring in an existing dummy, or for that matter an existing mechanism, and copy it into this mechanism. So you end up with the existing mechanism assemblies plus the new assemblies and connections from the dummy, all forming a new target mechanism. So how do we do this? Dummy assemblies come across verbatim. They're not changed at all. Dummies have connections obviously between parents and children. Where that child connection is about more than 1 degree of freedom, so that's typically a hip and an ankle, this becomes a pin joint in the target mechanism. If the old dummy definition had a constraint joint stiffness there to limit the rotational angles, then that too comes across verbatim and is honoured in the mechanism. This is a new capability in mechanisms. If the connection in the dummy was limited to rotation about a 1 degree of freedom, so that's typically the elbow and the knee, then we convert that to a mechanism hinge joint. And if there was a constrained joint stiffness to limit how far it could articulate, those plus and minus angles are brought across into the existing hinge joint limiting angular rotation limits. If a dummy had stretches, that's when mesh is distorted between 2 assemblies, that comes across unchanged. At the moment, if the dummy definition had contact between itself and the structure, that is not supported. The concept of structure is gone. Here we've got a dummy on the bicycle, and the mechanism of the dummy and the mechanism of the bicycle have been merged together, and I'm going to show how rotating the feet on the pedals actually causes the legs on both sides to move around together. So here we go. You can see I'm moving the left leg, and you should be able to see the right leg and the right knee joint moving in the background. it goes. So as this demonstration shows, the two mechanisms are actually working together. Right, now we're going to show what happens when we twist the handlebars. I've attached both hands to the handlebars and we'll try dragging this left hand. You can see the hands going round and the right hand's moving round and the torso is moving. Not entirely sure how realistic that behaviour of the right hand at the wrist is, but actually that's not our problem here. Let's just zoom out and you can see that the front of the bicycle's moved as well. So there's another example of using the same sort of methodology to move the whole of a dummy and a mechanism together. So to summarise, we can now convert dummies to mechanisms. This doesn't affect the original dummy, which can still be used. When you combine a mechanism converted this way with an existing mechanism, the old parent-child relationship no longer applies. The dummy and original mechanism definitions are now equal siblings and everything can affect everything else in a general way. We've had to upgrade pin joints in mechanisms to support stop angles, as defined by constrained joint stiffness, in order to apply the limiting angles in dummy joints, for example, which stop the elbow articulating backwards. Thank you.